Welcome back. Now we've created an actor and we call this BP field system. Now we can't really see it in our world, but if we search our outliner for field system, we'll see that it's right here. And if we press play, then it breaks our destructible mesh by creating some transient fields. Now this is a great system and we want to add this to our weapon. Now I'm going to keep our field system and all associated components on the blueprint side, as it's a lot of unnecessary work to get this worked into C++, and that's not really something you have to do with all your gameplay mechanics. I'd like to create a transient field initiated from C++ logic, but I'd like to actually add the components and add the transient fields in our weapon blueprint. So when that's the case, you can always add a blueprint callable function to your C++ class, and that's what we're going to do. So I'm going to open up my Visual Studio project. And here in our project, I'd like to open my weapon header file. So I'm going to go ahead and close out of all these tabs. I'll leave weapon.cpp open, and under weapons, here's weapon.h, and I'm going to add a protected function to create some transient fields. So this will be a void function. I'm going to call it create fields. And I'd like this to have an input parameter so we can know where that field should be. So this can be a const f vector passed by reference, and we can call this field location. And we can give this a u function. And since we want to implement this functionality in blueprints, we can make this a blueprint implementable event. So we'll give it blueprint implementable event. So we'll call this from C++, passing in the location where we would like to create those fields, and we'll handle the rest in blueprints. That means we don't need to create a function definition here in C++, but we do need to choose where to call this function. We're going to go to weapon.cpp, and right here in onBox overlap, we're performing our box trace. And as soon as we trace and hit an actor, I'd like to call our function create fields. So for now, we'll just call this inside of the if check for if box hit.getActor. So right here at the bottom, we're going to call create fields, and we can pass in the impact point. That's going to be box hit.impact point. So we'll pass that in, and now we can save all and hop back into the editor, and we can kick off live coding. So I'm going to click the recompile button. So with live coding finished, let's go into our weapon class. So we'll go to blueprints and items, weapons, BP weapon, and we should be able to right click and type create fields. And there's our event create fields, and it has this field location, which we're passing in from the C++ side. So we'd like to do what we did in our field system actor. So the first thing is we need a field system component. So we'll add that. We'll go to BP weapon, add, and search for field system. And there it is. We'll add that field system. And next, let's look at our field system actor. We need a radial vector, a radial fall off, and metadata. So we'll start with our radial vector, search for that, and add one. We'll also add a radial fall off. And finally, we'll search for metadata. And we'll get a metadata filter. So now that we have all the appropriate components, we can first configure our metadata filter. So let's select that, and we want our object type set to destruction. That way we're only applying these fields to destructible components. And next, let's look at our field system again. We're going to want to configure our radial fall off. Now, I like these parameters, so I'm going to copy this set radial fall off node and paste it here. And we're going to get our radial fall off and plug it in for the target. And we can call add transient field. So we're going to need our field system component, and we'll call add transient field. And we'll plug in our return value from set radial fall off for the field node. Now in field system, we see that we're using external strain and enable field. So we're going to set our physics type to external strain and check enable field and hook that up. Now we do need a center position, and we do have our field location. That's the impact point from our box trace. We're going to hook that in for the center position. And that's our first transient field. That's our external strain. Now we're also going to want a transient field using our radial vector. So we're going to call add transient field again. And we'll hook that up. We'll go ahead and check enable field and change this to linear force, as that's what we're using in our field system actor. Now we're going to want to plug in our field system metadata filter. So we'll get that and hook it into metadata. And for the field node, well, let's see what we did here. We got our radial vector and we set the radial vector. So I'm going to copy that node and paste it in right here and hook in my radial vector. And for the center position, I'm going to use that field location that we're passing in from C++. And we'll hook this in to the field node and compile and save. So now we should be creating fields when we get a valid hit from our box trace on our weapon. So we can simply remove this BP field system and press play. Well, it falls apart. And that's because we did go into our geometry collection and disable clustering. If we check that again, now it'll hold itself together, but what we want is to still be able to break it. So let's see if we can configure everything so that we can get exactly what we want. We want the pot to stay together until we actually hit it, at which point we should break it, right? So let's tweak these parameters a little bit. Now, first I need my geometry collection to generate overlap events, right? So if I search for collision, let's take a look at the collision presets for the geometry collection component on this geometry collection. So down here in collisions, first of all, I want generate overlap events checked. That's one. But I also do want my box trace to be able to hit it. And for that, I'd like to take a look at the actual geometry collection. If I go into Destructibles and open that, right here there's a drop-down that says size-specific data. And inside that we have an array element. And opening that, we have collision shapes, and that's an array. And inside of that, we have a collision type and an implicit type. Now, implicit type is convex, but I'm going to select capsule for this. I'd like to make this easier for us to get some hit events. And just to make sure that our hit events are working, I can go into BP weapon, and as long as we get a hit with that box trace, this event create fields will be fired off. So what I can do is simply draw a debug shape, such as a sphere, and the sphere can be drawn right here at the field location. So I'd like to just see if we're actually creating that field, first of all. So the radius is set to 100, segments 12. Duration, we can set this to 30 seconds, and we'll see what happens if we press play. Let's go ahead and swing the sword. So yes, we are actually getting our hit event. I'm going to set that radius to 25, just so we can see a little bit easier where that field is. So we are generating the field. So we know that that's working, but now we have clustering again. So that means we may need to up these forces. I'm going to add about 3 zeros to the field magnitude. So that is 6 zeros. So we have 1,000,000 again. And I'll add a couple zeros to the radial vector as well. That puts it at about 1.5 million. So let's go ahead and see what happens there. And we do get our pot breaking. So it's just a matter of tweaking parameters. And check that out. We have a really active piece there. That was kind of cool. So it's just a matter of tweaking parameters here. We just need to make sure that we have enough external strain to actually fracture the object and enough linear force to make those pieces fly all over the place. And setting that implicit type here to capsule just makes it a little bit easier for that box trace. You know, it's a little hard to see how that convex auto-generated collision algorithm works, but we really just care about actually getting a hit, not so much the accuracy of the collision shapes generated for our pieces or for the geometry collection as a whole. So I'm going to save that and close that geometry collection. And we now have this geometry collection that's configured just how we want it. We have generate overlap events. We've configured the collision on the object itself, and now our weapon is generating the appropriate forces to actually break it. And that's looking pretty good. I'm not going to want that debug sphere anymore. I'm going to go ahead and remove it, and we now have our weapon breaking these destructible objects. And that's great. Now, why would we even want to break objects? Well, some games allow you to break objects and pop items out of them, such as some sort of reward like gold, or perhaps an item like a weapon that we can equip. So it'd be nice to have a breakable object that does something in relation to gameplay, rather than just having cosmetic breakable objects, which is also nice. We can do that, but we can also create an actor that will do something for us, even if it's just as simple as getting some experience for breaking things, or a movement speed bonus for breaking a certain number of objects. Really, there's no limit to what we can do. And another thing is, as we're creating all these physics objects in the world, we would like to be able to destroy these after a while. So we'd like to create a breakable actor of some sort. Now, we do get this spinning because we are using capsules. And really, if you wanted those objects to not really roll around, you could change this to box instead. And we'll still get our collision on the objects, but we won't have them rolling around quite as much. So you may wish to have box instead of capsule there, and then they won't roll around. All right, so that's going to wrap up this video. Great job. We now have breakable objects, and we're smashing things with our weapon, and this is looking great. I'll see you in the next video.